Everyone, welcome to this video. We're still solving by trig. We're going to solve by trig. We're going to solve trig by factoring. All right, so the same process. We're just adding one extra step. We're going to factor. In this video, I'm not going to review how to factor. That's in other videos. I'm going to leave that to you. Okay, we're just going to go. This is a kind of review of how to factor a little bit, and then how to solve. So we're just going to jump straight to the back side. Notice that it says all of our angles are from 0 to 2 pi. Okay. Let's see here. So we have 2 sine of theta cosine of theta equals square root of 2 cosine of theta. Okay, now what I'm going to do, I'm going to show you a method where it's going to be a little bit easier. It's going to make more. I don't want to say it's going to make more sense because it's just factoring either way, but it'll be more recognizable to you. So I'm going to say let x equal cosine of theta and let y equal sine of theta. Okay. So here I have 2 times sine, but instead of sine, I'm going to write y, times cosine, but instead of cosine, I'm going to write x, equals square root of 2 times cosine, but instead of cosine, I'm going to write x. So square root of 2 times x. And that looks a little bit more familiar. That looks like something you probably would have done last year, right? Now when we're factoring, everything on one side, 0 on the other. So I'm going to subtract x squared root of 2 from both sides. So 2yx minus x squared root of 2 equals 0. Factor out the GCF, the greatest common factor. Well, here they both have an x. So the GCF is x. So I'm going to factor out an x. I have 2y minus square root of 2 equals 0. Now, when we have our factors, we set each factor equal to 0. So x equals 0. And 2y minus square root of 2 equals 0. So we're good here. We're going to stop there. Now we're going to get y by itself. Plus square root of 2. So 2y equals the square root of 2. Divide by 2. Y equals square root of 2 over 2. Now I'm going to take these. I'm going to replace cosine and sine. Right? X equals 0. Well, x and cosine are equal. So I'm going to replace x with cosine. So cosine of theta equals 0. And then I'll replace sine with y. Sine of theta equals square root of 2 over 2. Okay, to get theta by itself, take the inverse of both sides. So theta equals cosine inverse of 0. And theta equals sine inverse of square root of 2 over 2. Theta equals, what angles, when you take their cosine, give you 0? Well, that's pi over 2, 3 pi over 2. And then what angles, when you take the sine, it gives you square root of 2 over 2? That's pi over 4 and 3 pi over 4. Okay, and that's your answer. Okay, let's go on to the next one. So we have cosine squared of theta, this is squared, plus 6 cosine of theta, plus 5 equals 0. It already equals 0, so we're good there. I'm going to say let x equal cosine of theta. So instead of cosine squared, we have x squared plus 6 times cosine, so 6 times x, plus 5 equals 0. Now that looks a little bit more familiar. Factor this. We have to have x and x. Two numbers that multiply to 5 and add to 6 are 5 and 1. Set each factor equal to 0. Solve. x equals negative 5, x equals negative 1. Replace cosine with x. So cosine theta, or replace x with cosine, excuse me, equals negative 5, and cosine of theta equals negative 1. Take the inverse both sides. Theta equals cosine inverse of negative 5, and theta equals cosine inverse of negative 1. So theta equals, well, what angle, when you take its cosine, gives you negative 5? Look on your unit circle. There isn't one. So this is an extraneous solution. We don't use it. How about here? Look on your unit circle. What value or what angle, when you take its cosine, gives you negative 1? Pi. And it's just pi. There's your answer. Okay. Next one. We have 2 cosine squared of theta plus cosine of theta equals 0. It's already equal to 0 for us, so we're good there. We're going to let x equal the cosine of theta. So here, it's going to be 2x squared plus x equals 0. Factor out the common factor. They both have an x in them, so that's the greatest common factor. And we get 2x plus 1 left over. Set each factor equal to 0. X equals 0. 2x plus 1 equals 0. We're done here. Let's get x by itself over here. Minus 1 both sides. Divide by 2 both sides. So x equals negative 1/2. Okay, now replace x with cosine. So cosine of theta equals 0. Cosine of theta equals negative 1/2. Take the inverse of both sides. I'm going to move up here. So theta equals cosine inverse of 0. And theta equals cosine inverse of negative 1/2. Ooh, that was bad. So theta equals, well, what angles, when you take their cosine, gives you 0? Pi over 2, 3 pi over 2. What angles, when you take their cosine, give you negative 1/2? That is 2 pi over 3 and 4 pi over 3. And those are your answers. Okay. Let's do this next one. Sine squared of theta minus 1 equals 0. So I'm going to say let x equal sine of theta. So instead of sine squared, I'm going to have x squared minus 1 equals 0. Add 1 to both sides. X squared equals 1. Square root both sides. X equals plus or minus 1, right? The square root of 1 is 1. So I'm going to replace sine with x, or x with sine, excuse me. So sine of theta equals 1, and sine of theta equals negative 1. Okay, let me lock the door real quick. All right, take the inverse both sides. Theta equals sine inverse of 1, and theta equals sine inverse of negative 1. All right, so now theta equals, let's see here, what angle do you take the sine of to get 1? That's pi over 2. What angle do you take the sine of to get negative 1? That's 3 pi over 2. There's your answer. The next one here. 4 times the tangent squared of theta minus 1 equals tangent squared of theta. Okay, so let x equal the tangent of theta. So now we have 4x squared minus 1 equals x squared. Okay, when we factor, everything on one side, 0 on the other. So I'm going to subtract x squared from both sides. So 4 minus 1 is 3. 3x squared minus 1 equals 0. Add 1 to both sides. 3x squared equals 1. Divide by 3 both sides. X squared equals 1/3. Square root both sides. X equals plus or minus the square root of 1/3, which is plus or minus 1 over the square root of 3, right? Square root of 1 is 1. Square root of 3 is square root of 3. Okay, now simplify, rationalize the denominator. We get plus or minus the square root of 3 over 3. So we have tangent of theta is equal to positive square root of 3 over 3. And tangent of theta equals negative square root of 3 over 3. Take the inverse both sides. Theta equals tangent inverse of square root of 3 over 3. And theta equals tangent inverse of negative square root of 3 over 3. So theta equals, well, what angles, when you take their tangent, you get square root of 3 over 3? That's pi over 6 and 7 pi over 6. And then what angles, when you take their tangent, you get negative square root of 3 over 3? That's 5 pi over 6 and 11 pi over 6. And those are your answers. Right. Next one. Cosecant squared of theta plus 4 cosecant of theta plus 4 is equal to 0. We're going to let x equal the cosecant of theta. So here we have x squared plus 4x plus 4 equals 0. Factor this. We get x and x. Two numbers that multiply to 4 and add to 4 are 2 and 2. Set each factor equal to 0. Subtract 2 both sides. X equals negative 2. X equals negative 2. So since we have the same solution, I only need to do it once. I'm not even going to worry about that one because I got the same solution. So let's see. Cosecant of theta is equal to negative 2. Now, cosecant isn't on your unit circle, right? I mean, it's on it, but you don't have it written down. So let's switch it to sine, right? We'll take the reciprocal. So sine of theta, right? Sine is the reciprocal of cosine, so I'm going to take the reciprocal of negative 2, which is negative 1/2. Take the inverse both sides. Theta equals sine inverse of negative 1/2. So then theta equals, what angles? When I take their sine, I get negative 1/2. Well, that is 7 pi over 6 and 11 pi over 6. Okay. Now we have 2 sine squared of theta minus 5 sine of theta plus 3 equals 0. We're going to let sine of theta equal x. Make sure that we're still going here. Yep. So let's see here. Now we'll have 2x squared minus 5x plus 3 equals 0. Factor this. So this is going to be 2x and x. Let's see here. We're going to have minus 3 plus 1. Right? Nope. Sorry. I don't know if you can factor that. Oh, no, you can. Okay, let me factor in my head real quick. Sorry, I'm doing this in my head right now. So we got 2x squared minus 3x minus 2x plus 3. So we got, oh, it's minus 3 minus 1. That looks better. There you go. Okay, set each factor equal to 0. 2x minus 3 equals 0. X minus 1 equals 0. Add 3 to both sides. 2x equals 3. Divide by 2 both sides. X equals 3 halves. And add 1 to both sides. X equals 1. So now convert back to sine. So sine of theta equals 3 halves. Sine of theta equals 1. Take the inverse both sides. Theta equals sine inverse of 3 halves. Theta equals sine inverse of 1. All right. What angle, when you take its sine, gives you 3 halves? Well, none of them, right? Remember, amplitude of sine is 1, so it'll never be greater than 1. This is 1.5, right? It's more than 1. So this is an extraneous solution. We're not going to use it. So how about here? What angle, when you take its sine, gives you 1? Pi over 2. And that's your answer. Okay, let's see here. I think this is the last one. Yeah. Cosine squared of theta minus 4 over cosine of theta minus 2 equals 1. We're going to let x equal cosine of theta. So here we got x squared minus 4 over x minus 2 equals 1. Okay. Now what we're going to do, you could potentially factor this and then divide out, but if x equals 2, then you have a divide by 0 situation. Now in the long run, x can't equal 2 because cosine can't be greater than 1. But we're going to do it a different way. We're going to multiply both sides by x minus 2. So these reduce. X squared minus 4 is equal to x minus 2. Subtract x and add 2. So x squared minus x minus 2 is equal to 0. Factor it. X, what is this, minus 2 times x plus 1 equals 0. Set each factor equal to 0. Solve x equals 2, x equals negative 1. So you see what I did? Like I said, you could have factored x squared, x plus 2 times x minus 2 first, and reduce the minus 2's already, and you'd have x plus 2 equals 1. And then subtract 1, and you have x plus 1 equals 0. You could have done it that way, but that only works here because this is a minus 2. Okay, and cosine can't equal 2. Cosine of theta can't equal 2. But if this was a minus 1, then you couldn't do that. You would have to do it this method. And then you go back and check your work. Okay. So replace x with cosine. So cosine of theta equals 2. and cosine of theta equals -1. Take the inverse both sides. Theta equals cosine inverse of 2. Theta equals cosine inverse of -1. Theta equals, well here, what angle can you take the cosine of to get 2? None of them, right? Amplitude is 1. So that's an extraneous solution. I'm not going to use it. Then here, what angle do I take its cosine and I get -1? Pi. And there's your answer. Okay. So same process as last video. We just added in some factoring. That's all. Now, like I was saying at the very beginning, you don't have to use this method if you can factor this just off the top of your head. Okay. As you practice, and you need to practice, as you practice, you'll probably get to that point where you can just factor off the top of your head, just using cosines instead of x's. But I recommend, until you're at that point, convert it to x, because then it looks really familiar. Right? It looks like the stuff you did last year in SM2, and this looks like stuff we did this year with rational equations. Right, but that's it for the video.